Every day, Pinterest runs thousands of experiments to determine what features to implement to improve the experience for their 454 million users and drive business value. Billions of records are processed for the daily 10 a.m. deadline, so that teams who depend on experiments results can hit the ground running and make well-informed decisions. At the heart of what's required to do this is a reliable and scalable data processing pipeline. Between 2015 and 2017, Pinterest's user base grew from 100 million to 175 million. And in that same period, the number of running experiments doubled. This rapid growth meant that the legacy system, which used Hadoop to process data stored in Hive, couldn't process data in time for the daily deadline. And that meant that teams couldn't make data-driven decisions quickly. Pinterest needed to revamp their legacy experimentation data pipeline into one that could handle the current load and scale beyond. They knew that the pipeline had three main requirements. One, it had to be extensible enough so that new metrics could be added and backfilled historically. Two, it had to be able to process and store large amounts of data generated by a rapidly growing user base and number of experiments. Three, it had to be able to compute and serve accurate metrics on dashboards based on both historical and recent data. So how did they do it? Kafka is used to ingest data from both events on the app and programmatic interactions from the developer API. Then it sends it both to the batch layer and the streaming layer. The new pipeline implemented is a Lambda architecture, where you have both a batch processing pipeline and a real-time streaming pipeline in parallel, using different tech stacks. Batch processing provides comprehensive and accurate views of all historical data, while the streaming pipeline does real-time stream processing to provide views of recent data. The outputs of the real-time and batch processing can be joined at the end. Let's zoom in on the streaming layer. The streaming layer processes data as soon as it comes in. Metrics that you want to know as soon as possible, like ad clicks or number of active users, are processed in real time by the streaming layer. For applying transformations like cleaning and computing features from raw data in real time, Spark Streaming was an obvious tool for the job. Compared to processing data using Hadoop, as in the legacy system, Spark can be up to 100 times faster. That's because it performs operations in memory instead of reading and writing data to a hard disk. This reduces the execution time of running a new job from over 4 hours to well under 2. The processed data is then sent to a MemSQL database as an intermediary data store, which serves the analytics dashboard where the data can be queried in real time. In parallel to that stream processing layer, we have the batch processing layer, which runs queries on the whole dataset together. If we want to find the value of a metric that depends on historical data, such as the most popular category on Pinterest this year for women aged between 25 and 30, then we would use the batch layer. Kafka dumps all of the raw data directly to an S3 bucket, and this is where the batch layer starts. It can stay here for long-term persistent storage, but it's also sent to Apache Spark. Spark performs transformations on the raw data to clean it and compute any required features. Spark doesn't run automatically, so those Spark jobs are triggered using Pinball, an orchestration tool much like Airflow. At the end of the batch layer, the data is inserted into HBase. From HBase, metrics can be served to the experiment dashboard. Presto is the final missing piece of the batch layer. It allows other data teams to run ad hoc queries on the raw historical data in S3. Together, the MemSQL database in the streaming layer and HBase in the batch layer make up the serving layer, which serves data to the dashboard. The new pipeline not only addresses the previous problems, but will continue to deliver experiment results accurately, effectively, and on time, so that Pinterest's engineering teams can deliver value to millions of pinners for years to come.